Hey everybody, our lesson today is on fractions part 7. The topic is to subtract fractions with like denominators. Remember that the denominator is the bottom number of a fraction, and like denominators means that it's the same. For example, 8/10 minus 3/10. The tenths are the same, and that's what we mean by like denominators. So the rule in math is that when you subtract fractions with like denominators, that you only subtract the top numbers. So for example, in this case, 8 minus 3, that would be fine. But you do not subtract the bottom. In fact, the bottom has to stay exactly the same. I call it boom, boom, boom. In other words, 10, 10, 10. That's a math rule. That has to be the same. So boom, 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 or 10, 10, 10. And we would say 8 minus 3 would equal 5/10. So our answer would be 5/10. On the model, you could show that as 8/10, which is 1, 2, 3, 4, 5, 6, 7 is the 8 shaded. And we could take away 1, 2, 3, which is here. And that would leave us with a total of 1, 2, 3, 4, 5 tenths, because these are all tenths. And so that's how we do that today. When you subtract fractions, add or subtract fractions, remember we only work the top numbers called the numerators. So yes, this is the right way to do it. And think of it this way: if you had 10 watermelons, and your family eats 4, so you've taken 4 away, 4 watermelons, you are left with 6. But 6 what? 6 watermelons. So that would be the correct way. The watermelons don't change into something else. Now, the wrong way to think of it is to think, well, if you have 10 watermelons and you eat 4 watermelons, that you have 6, but somehow the watermelons turn into strawberries. Well, that wouldn't be correct. And it's the same way with fractions. It's boom, boom, boom. The bottom has to stay the same. We can show it with models also. For example, 9/12 minus 3/12 equals 6/12. So boom, boom, boom. So this is the right way to do it. And notice we only changed the subtracted the top. 9 minus 3 equals 6. I can show that with models here. These are 12ths, so let's get some 12ths in here. I think we have 9 of them. That's 4. This would be 6, 8. I think this is 9. I will double check in a second. Scooch that up a little bit. So we have all 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is our 9/12. And we take away 3 of them. So I'm going to take away 1, 2, 3. We'll get rid of those ones there. And notice that we are left with 1, 2, 3, 4, 5, 6. But 6 what? Notice these are all 12s on your denominator on the bottom. So that's what we mean, to model it that way. Now, how not to do it is if you were to say, well, I'm going to go 9 minus 3 is 6. And that part's actually okay. But then you say on the bottom, 12 minus 12 equals 0. That would leave you with 6 over 0, or 6 zeros. In other words, you have 6 of nothing. And 6 of nothing is absolutely nothing. I'll prove that with a calculator. We said in an earlier lesson that a fraction is a division statement. So we could say that 6 divided by our 0, in this case on the bottom, and guess what that's going to equal? A big fat 0. So that would be nothing. So we definitely do not subtract the bottom. We can use models to find the difference. Remember, difference is subtraction is the answer in subtraction. This would represent one whole. Looks like we have tenths here. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have tenths. and we have 7/10. I'm going to label those. We're going to use our unit fractions. So 1/10, and all of these would represent a tenth, right? Or in other words, a unit fraction of 1/10. Remember, a unit fraction always has a 1 on the top. So here we have our tenths. We have 7 of them, and we're going to take away 3. So we'll take those away, and these are the ones that we still didn't cross off that we have left. Notice that we have 1, 2, 3, 4, right? And what do we have? We have 4. All of these are tenths. So boom, boom, boom. Our answer is 4/10. Let's try another one. We're going to use the model to find the difference. Here is our one whole. Looks like we have fifths this time. 1, 2, 3, 4, 5 equal pieces. Let's label with our unit fractions. This would be a fifth. This is 1/5. All of these are fifths. Remember, these are unit fractions with a 1 on top. That's our 4/5, and we're taking away 1. And that would leave us with 1, 2, 3. Remember, 4 minus 1 is 3. Am I going to subtract here? No, we're going to go boom, 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 and our answer would be 3/5. Let's try subtracting without models. Let's do one together. 9/12 minus 5/12. Well, on the bottom, boom, 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 right? Our 12ths, and 9 minus 5 is 4. Go ahead and try these. Go ahead and pause for a second. Try them. All right, and let's solve. 4/8 minus 1/8. Well, this is easy. 8, 8, 8, and 4 minus 1 is 3. 9/10 minus 3/10. Boom, boom, boom on the bottom. And 9 minus 3 would be 6/10. 5/5 minus 2/5. 5, 5, 5. 5 minus 2 is 3. 7/12 minus 6/12. Boom, boom, boom on the bottom. And 7 minus 6 would be 1. And finally, 2/4 minus 1/4. Our fourths, and 2 take away 1 would be 1/4. So in review today, our lesson on fractions is subtracting fractions with like denominators. Remember, like denominators means the bottom number is the same. In math, to add or subtract, they must be the same, and these are the same, that's fine. But we only do the top. The bottom, everybody, is boom, boom, boom. In other words, it must stay the same. All right, thanks, everybody.